Hello everyone, my name is Hakim and today we are conducting an experiment on pipe flow. This is a lab report for MEB2043 Fluid Mechanics. This lab video is a review of the work of a group of fluid mechanics students residing at University of Toledo. This video follows the order of physical lab whereby we will talk about the introduction of the experiment, the objectives of the experiment, the methodology of the experiment, the result, the discussion, and finally the conclusion. Now, this experiment consists of two experiments whereby we are trying to figure out the coefficient of friction or Darcy friction factor, which affect the head losses during the transportation of fluid in a pipe. As you can see on the screen, it has been determined that the fluid transported through pipes and fittings experience head losses due to the friction due to the walls of the pipe and changing flow direction through fittings geometry. Now, a bit review on the theories that we have to understand before conducting this experiment. There are four formulas that we have employed throughout the experiment. They are head loss due to pipe flow equation, derivation of head loss equation for friction, which is the derivation of the first formula that I mentioned, which is the head loss due to pipe flow, and the second one is Reynolds number. The third one is Reynolds numbers equation. Now, the objective of this experiment is to observe how friction affects a flowing fluid as it travels through a conduit and fittings for various flow rates. So the methodology of this experiment, as I mentioned before, we have two experiments, and the first experiments we used the pipe test rig, and the second experiment we used copper pipe. So for the first experiment, we have to for both of the experiment, both of the procedures requires the experimenters to conduct a test on the pipe test rig. This is to simulate the environment in which the water flows through. The property of the pipe for experiment 2, which is the copper pipe, is different. We are using copper pipe due to its superior properties. Now, if you notice in the first experiment, we are using LabVIEW software, which we use to determine the friction factor and the Reynolds number easier. And for experiment 2, we are using the physical lab equipment, such as the beaker, which we would use to measure the water that is flowing out of the pipe. And now, for the figures of the experimental setup, we are utilizing LabVIEW software. This is on the top right, we have the pipe test rig, and at the bottom left, we have the copper pipe, and this is these are the four main equipments that we have to have to conduct this experiment. Now, for result and discussion, after we conducted the experiment, we have to discuss about the results that we received from the experiment. Since we are trying to determine the friction factor for fluid flowing in the pipe, we have to use the Moody diagram, the one on the screen in front of you, where we have to plot for the Reynolds number and the friction factor. According to the experiment conducted by the students, it was found that the friction factor, which is in the experiment 1, it was 0.022484, and for experiment 2 is 0.015318. And mind you that there's no unit for friction factor since it is a coefficient. Now, what does these two values tell us? So the value obtained from the diagram denotes that the data from the experiment does not fit the exact curve on Moody diagram. Now, there are several factors that could divert the data from being identical to the one shown on the Moody diagram. One of it being the condition of the lab equipment, which affects the accuracy of the result. But nevertheless, despite the error, the result was accurate in the sense that it supports our theory that friction has significant impact to the flow of a fluid, in a pipe. Now, from the experiment, we can conclude that the fluid traveling through pipe systems result in a pressure losses due to friction. It has been observed that the effects of pipe friction and minor losses due to different flow rates through different pipe sizes. It's basically saying that what we're trying to observe from the experiment, which is the friction loss, really affect the head losses in the pipe, which can be which will be different depending on the flow rate and the size of the pipe. So that's all from me. Thank you for listening and have a good day.